All right, today we're going to talk about geomorphology. So, geomorphology is about the shape of the Earth and how the shape of the Earth changes over time. So basically, if we think about what the surface of the Earth looks like and the kinds of landforms that exist there, we know that that is an ever-changing process, and there's an image on the right-hand side of this slide that shows how a landscape in the first picture might be eroded and then start to look like picture 2, and over time that could turn into picture 3, which could turn into picture 4. And so we know that these are changing over time, and we discussed the fact that there's different categories of processes, endogenic and exogenic processes, that contribute to the change of landforms over time. So endogenic processes are those that are initiated from forces within the Earth, like the movement of plates, volcanic activity, earthquakes, etc. Whereas exogenic processes are the forces that occur from outside the Earth, so things like wind and water and ice flow. Those things affect the solid Earth surface from the exterior. And typically the endogenic type processes are the processes that are going to create uplift on the landscape, basically create mountains and push landscapes upwards, whereas the exogenic processes are typically doing work to erode the landscape away and change its shape, and by moving material around over time, but generally carrying material downhill from higher elevations to lower elevations. So just as a bit of a reminder, we talked about a couple different kinds of processes that can lead to uplift activity in mountain building in the last several lectures. Generally different kinds of plate tectonic activity that can be related to convergence of plates or divergence of plates, that might be related to the creation of volcanoes, which blister up on the landscape and make mountains. That is certainly a kind of uplift. But volcanoes aren't the only kinds of processes that can create uplift. In places where continents are colliding with one another, there can be folding of the Earth's surface to create mountains, or there can be cracking in the Earth's surface and movement vertically along faults that can build mountains as well. So we talked about all those examples, and those are all, again, examples of exogenic type processes. And we haven't spent as much time talking about the other kinds of forces that might be involved in tearing landscapes down over time and redistributing material across the Earth. So generally, there's a process that's called weathering, which can be defined as the aging of rocks to produce sediments. So sediments, we might remember from our discussion about soils, are loose fragments of rocky mineral material. And these sediments are created through weathering, and there's different kinds of weathering. There's both chemical weathering and physical or mechanical weathering. So chemical weathering is when we have processes that are related to chemical reactions that are actually eating away at the surface of the rock. So maybe the rock is exposed to some sort of organic acid that is extruded by a lichen, or maybe the rain that's falling on a rock is slightly acidic and that's eating away at the rock. Or maybe just water itself, not necessarily water that contains acid. Maybe that water is reacting with the rock surface and removing some of the atoms from the rock surface over time. And that is called chemical weathering. On the other hand, physical weathering occurs when there's a physical force that's pushing or pulling on a rock that's causing it to break apart. So maybe there is a rock from above that falls down and crushes a rock as it collides with another solid surface below. Or maybe the wind or the water is pushing against the rock and slowly over time breaking it apart. Maybe plant roots are growing into cracks in rocks and fracturing them. Or maybe ice crystals are growing in fractures in rocks and cracking them as well. So all of those would be physical or mechanical weathering processes. But in both cases, one thing that's important to keep in mind is that the chemical and physical conditions that exist on the Earth's surface where weathering is occurring are very different than the conditions where most of the rocks formed underground. And this kind of shift in the environment is one of the things that makes these rocks more susceptible to weathering and allows them to break down over time as they're exposed at the surface. So by force or by pressure is physical, by chemical reactions is chemical. So one thing that we often observe on the landscape is that there'll be rocks nearby other rocks that are susceptible to weathering, whereas nearby landforms will be more resistant to weathering. And so we call this differential weathering, where one surface will be weathering at a different or faster rate than an adjacent surface. And a lot of times this is what leads to some really interesting topographic features that we can observe around the Earth. So here's a picture of the Grand Canyon, and you can see the walls of the Grand Canyon aren't straight up and down, but there are certain rocks that have been a little bit more resistant to weathering over time that have held up better, and those appear as kind of more sheer, steep-sided faces that are existing more substantially still today, whereas other landforms have been a little bit more susceptible to weathering, and so they have been eaten away by this weathering process more successfully over time, and they look more like eroded faces. And so in this case, in the Grand Canyon, we have certain kinds of metamorphic rocks that have been very resistant, and then we've had other kinds of sedimentary rocks that have been more susceptible to erosion. And again, that creates kind of the shape, the geomorphic features of the landscape over time. Some more examples of this include differential weathering of other kinds of rocks in our region. So when we talked about volcanism before, we mentioned that a lot of times magma actually cools underground to form rocks, and the granite that makes up a lot of the Sierra Nevada that we can see up near Bucks Lake, but also in famous features like Half Dome or El Cap in Yosemite, were created by the cooling of these magma chambers underground. And that granitic rock is very resistant to weathering, and over the last 100 million years, since these magma chambers existed, the surrounding rock has eroded away and left these big granite domes protruding up out of the landscape. So another landscape feature that's created by differential rates of weathering of nearby geologic material. Other examples include volcanic necks. So a lot of times the magma and lava that's coming up to the surface of a volcano will cool and solidify inside the volcanic neck, sort of that channel that the material was traveling up, and those rocks will be more resistant to weathering than the landscape around it. So here is kind of a red line showing where the original volcano would have been, and then you can see that today the volcano is gone, but the volcanic neck is still there. This is a famous feature that's called Devil's Tower, and we have some of these features locally as well. In this case, about 16 million years ago, there was a big lava flow in our area that came from northeast of us and flowed down kind of the current day Feather River area and into some ancient river channels in the Oroville and Chico area. The lava was a liquid, so it kind of followed the path of least resistance, and it accumulated in this ancient river basin, and then it cooled off to create a flat surface. And over the last 16 million years, the sedimentary rocks on either side of that old river channel have eroded, and we have a feature that's called Table Mountain that is left behind. So anyway, the weathering process and the difference of rates of weathering experienced by different areas are often what leads us to have these different kinds of interesting surface features on the landscape. And so this is one thing that geomorphologists are very interested in trying to learn about and understand. Another thing that I'll say on the topic of weathering is that weathering is the breakdown of rock And the next step after rock starts to break down is the movement or the erosion of that rocky material. And sometimes that loose rocky material is moved by wind and water. It's often accelerated by that. But gravity is also a really important force in just carrying materials downhill, kind of tearing away the uplift that has previously occurred in certain areas. So there's a special term called mass wasting that refers to erosional processes that are due to gravity, this force that's pulling all these objects with mass down towards the surface of the earth and the core of the earth, if that would be possible. And so there's different kinds of events that occur that are within the category of mass wasting. So you've probably heard of landslides or avalanches. I have some images here for you guys to imagine how this works. And those are both examples of where geologic material is moved downhill through the force of gravity, or those are examples of mass wasting. Sometimes mass wasting is less dramatic as a landslide or an avalanche. So there's also processes like soil creep, where individual soil particles kind of slowly roll and slump downhill over time. So there's a picture in the center of the slide here that shows these kind of little layers of soil that are sliding down the slope over time. And even though these processes are much less dramatic than the big processes, they're going on all the time. So over geologic time, they add up to quite a bit of movement of material downhill and quite a bit of change to landscape form. So when we're trying to understand where mass wasting might be occurring more frequently and more quickly as opposed to where it may be occurring more slowly and more gently, there's a couple different kinds of factors that we want to consider. So one is related to friction. If there's greater friction in between surface sediments and other sediments and solid rock below, then the geologic material is more likely to stay in place. So usually when these materials are dry, they have a little bit more successful friction, and also when they're wet, the water can actually act like a lubricant and can decrease that pressure, or that friction, excuse me. Another thing is rock strength. Certain rocks are just more able to hold up over time, and other rocks are less able to do that. So that may change the susceptibility of different materials. And then also the slope of the landscape. So if you have a really steep slope, then that gravitational pull is going to be felt a little bit more extremely than on a shallow slope where things are a little bit more likely to allow friction to overcome the force of gravity pulling them downhill. So I guess the last thing to mention would be that in addition to water's influence on friction, basically reducing the friction between different soil particles or between soil and hard rock below, another thing that happens is when landscapes get wet, that they're heavier, right? As the water gets into fractures in rocks and gets into soil, it makes that landscape a little bit more massive, and that's another thing that would make it more susceptible to sliding downhill, because we know that gravity is influenced by mass of different objects. So if that hill slope is just more heavy, it's more likely to end up tumbling downhill. So anyway, these are examples of the kinds of things that might contribute to the tear down of landscapes over time, which is one component of geomorphological change.